Hey everyone, welcome back to my channel Landscape Detective. Today we are taking a deep dive into three fascinating landscapes: the vast Arabian Desert, the mighty Mississippi River, and the breathtaking Maldives. Each of these locations tells a unique geological story, shaped by different natural forces over time. So let's break it down. How do wind, rivers, and ocean currents shape the land? And what kind of rocks do they leave behind? Let's find out. First up, let's talk about the Arabian Desert, a vast expanse shaped predominantly by wind-driven sediment transport and deposition. Located in Saudi Arabia, this region features an array of aeolian landforms, including extensive dune systems, deflation surface, and rocky outcrops. Wind erosion and deposition are key players here. It picks up fine particles and carries them away, leaving behind larger grains. This process is called deflation. Over time, this can create rocky surface known as desert pavement. Then we have the dunes themselves. Depending on wind direction and speed, they form different shapes: Balkan dunes, transverse dunes, and star dunes. These dunes aren't just piles of sand, they actually record wind patterns and climate change over time. The image shows multiple undulating depressions, identified as deflation hollows, formed by continuous removal of fine-grained material due to wind erosion. Locally elevated areas may be lag deposits, where coastal particles such as heavier gravel or cement sandstone blocks accumulate. The low-lying areas between dunes may be dune troughs, where there is less sedimentation due to lower wind speeds, forming flatter intervals. The second factor is intermittent river actions, shapes dry riverbeds, wadi, depositing sediments in alluvial fans or mudflats during heavy rainfall. If we let these dunes solidify over millions of years, we'd get cross-grained sandstones, and in rare cases, if there's seasonal rain, we could get conglomerate layers forming in between, and some highlight will leave after evaporation. Here is some pictures of environment and specimens of various kinds of rock. One of them is from my sketch. So, the Arabian Desert is a giant windscarp landscape with potential to form stunning sandstones that preserve a record of past climates. Alright, now let's shift gears, literally to the Mississippi River, one of the most powerful and ever-changing rivers on Earth. If you've ever seen those classic looping bends in a river, you're looking at a meandering river system. The area we talk about today is located within the Mississippi River Basin. It's shaped by powerful hydrodynamic force that driven erosion, deposition, and channel migration. So, what's happening here? On the outer banks of the river, strong currents erode the banks, creating steep cut banks. Meanwhile, on the inner banks, the water slows down, allowing sediments to settle, forming point bars and mid-channel bars, basically made of sand and silt. These arrows point to different sedimentary features represented by different regions. Now let's focus on the cross-section profile. From the graph, it is clear that elevation ranged from 71 to 77 meters, indicating a relatively low relief terrain with minimal elevation variation. The localized drop in slope may indicate an erosion zone, where sediments are being transported downstream or redistributed across the sandbar. In high-energy regions, sediments are eroded, while in low-energy zones, they accumulate, contributing to elevation variations. Flooding plays a huge role here. When the river overflows, it deposits fine sediments on the floodplain, creating features like natural levees and bank swamps. Over time, this builds up layers of sediments that can turn into rock. So, what kind of rocks could form here? If we fast forward millions of years, These river deposits could harden into sandstone and siltstone. What about the fine clay from floods? That could turn into mudstone or even shale. And in high-energy areas with larger particles, you might even get conglomerates forming. Here is samples of different rock, not only the mixture of sandstone, siltstone, and shale, but also conglomerates from my daily sketching. In short, the Mississippi River is a sediment factory, constantly eroding, transporting, and depositing materials that could one day become solid rock. Last stop, the Maldives. Unlike the river or the desert, this landscape is built by living organisms. Located in the South Mal Atoll, Central Indian Ocean, we are taking coral reefs, which create entire islands made of calcium carbonate. Over time, these reefs grow, break down, and reform into limestone structures. So, how does this work? Situated atop the Maldive Range, a submerged volcanic plateau, wave sand tides then redistribute this sand, forming sandbanks, shells, and even islands. Some areas are more stable, while others constantly shift due to tidal scoring. In deeper water channels, fine carbonate mud is often removed by currents, leaving coarser debris like shell fragments. In addition, the presence of light blue shallow areas signifies active coral reef growth, which produce new carbonic sediments that accumulate over time. When corals die, the skeletons break down into carbonate sand. Fast forward in time, what do we get? The reefs themselves form reef limestone, the core sediments and sand waves turn into crossbed limestone, a type of rock made from tiny carbonate spheres. And in high-energy tidal zones, we find bioclastic greenstone and limestone, filled with broken shells and coral fragments. Essentially, the Maldives is a living, evolving limestone factory, constantly recycling and redistributing calcium carbonate. So, what do these three places have in common? They are all shaped by natural process, whether it's the movement of wind, water, or ocean currents. For Arabian Desert, wind-driven dunes from crossbed deposits leading to sandstone. For Mississippi River, erosion and deposition create crossbed sands, which may liquefy into conglomerates, siltstone, or mudstone. For Maldives, waves, tides, and reef growth produce carbonate sands, forming greenstone or bioclastic limestone. Each environment leaves behind a unique geological fingerprint, helping us understand Earth's history and how landscapes evolve over time. Finally, it is a wrap for today's episode. If you enjoyed this deep dive into sedimentary environments, make sure to like, subscribe, and let me know in the comments which landscape fascinates you most. See you next time for another exploration into Earth's incredible geology. Bye bye!